All right, guys, I'm going to try and make adding and subtracting red light fractions a little bit quicker. We should be pretty good with this. These are definitely red light fractions. You can see that our denominators are different. They're not green light. We cannot turn a 3 into a 5, which means we're going to end up having to change both of them. So when the first step is denominator, obviously they're dreaded red. So our first step is to draw the M. And we want to find the least common multiple of our denominators. 5 is our first snowball, 3 is our next snowball. I'm going to struggle to do this neatly, but if I list the multiples of 5, we're going to count by 5s, 5, 10, 15, 20, 25, and I'm going to do the same thing with 3 and kind of keep my eyes open for if I'm matching any of those. 3, 6, 9, 12, 15, and I can see right there my least common multiple is 15. So what that means is I am going to be changing each of my fractions into a denominator of 15. And so I'm just simply going to take 2/5, just like we did before, and I'm going to Watudamadud into a 15. I'm also this time going to have to take 1/3, and I'm going to have to Watudamadud into a 15. To create those equivalent fractions. My Watudamadud here is going to be times 3, so 2 times 3 is 6. So 2/3 can become 6/15. And then over here, I need to Watudamadud by 5 to get from 3 to 15. And so I'm going to do the same thing for the numerator. That creates a new fraction of 5/15. So I'm going to rewrite the entire problem. Instead of 2/5, I'm going to say it's the same as 6/15. Instead of 1/3, it's now going to be 5/15. And this is a subtraction problem. So it took me a little bit longer to get that common denominator, but you can see I have a common denominator of 15. I'm now going to go ahead and add or subtract. This is a subtraction problem, so if I'm starting with 6/15 and I take away some 15ths, I'm going to have some 15ths left. The question is how many? If I have 6 and I take away 5, I'm only left with 1. So now I have my answer. The question is this the best possible answer? It is not improper, so I don't have to worry about that. And I can actually see 1 and done. Numerator's 1, so it's in simplest form. So my final answer would be 1/15. That was a terrible circle, sorry. Let's try one more. Another dreaded red. You can see there's nothing I can do to turn a 4 into a 5. So I'm going to have to do my M. And I'm going to take my 4 and my 5, my uncommon denominators, and they are going to become the snowballs on my mountain. And I'm going to go ahead and list my multiples of 4, 4, 8, 12. 4 times 4 is 16. 4 times 5 is 20. I'm going to go down this side. 5 times 1 is 5, then 10. 5 times 3 is 15, 20. And I was kind of keeping my eyes open, and I see that that least common multiple is 20. That means I am going to change both fourths and fifths into a new denominator of 20ths. And that's going to give me the common denominator I need. So I'm going to say, well, 3/4 is what it started as, but I need to turn 3/4 into 20ths. And I'm starting with 2/5 over here, but I'm going to turn those into 20ths also, so that we can get that common denominator. When I would Watudamadud and make my equivalent fractions, 4 times 5 is 20, so 3 times 5 is 15. And here I need a Watudamadud to get from 5 to 20. That would be a Watudamadud of 4, and 2 times 4 is 8. So what I'm going to do now is I'm going to rewrite 3/4, and instead of saying it as 3/4, I'm going to call it 15/20. They mean the same thing. And instead of calling it 2/5, I'm going to call it 8/20, because that's the same thing. And this is an addition problem, so I'm going to stick an addition sign in there with my equal sign. I finally have that common denominator of 20ths. So now it's time for me to add or subtract. If I have 15/20 and I add more 20ths to it, I'm just going to have even more 20ths. Question is how many? Well, 15 plus 8. Even if you need to set up a little addition problem off to the side for accuracy, 5 plus 8 is 13, carry the 1, 1 plus 1 is 2. We have a bunch of 20ths, we have 23 20ths. So that gets us our answer. Question is this the best possible answer? Unfortunately, it is improper, so I am going to have to take a second to turn 23/20ths into a mixed number. And I don't know if we've dealt with 20ths before, but we are going to make a certain number of wholes and then have a certain number of 20ths left over. If I have 23/20ths, I can only make one group of 20, which would use up 20, and I have 3/20ths left. So that takes care of the I step. I cannot see one and done with 3/20ths, so I need to draw a little F. You can see all the work that goes into some of these dreaded red. What's nice about 3 is it's a beautiful prime number, so the only numbers I need to think about are 1 and 3. There's nothing times 3 that can make 20, because 3 times 7 is 21, so 3 is not going to work, so we are 1 and done. So my final answer, if I was going to write it, is 1 and 3/20ths, because we are in simplest form, and that would be my final answer. Time for you to try some.